Hi, I'm Greg. Welcome back to the channel. I've got a big project just started here. I'm building a 72 by 2 bench grinder. This is the VFD. I'm just doing some initial wiring here. Going to be a big multi-week, if not month job that I'll video as I go along. And meanwhile, I thought I'd do a little segue here and show you something completely different, which is how I've set up on my PM-30 milling machine here. Vertical, a Z-axis power feed, and a horizontal X-axis power feed using just car wiper motors. That's been working very well for me, so I think I'd just give you a little tour of what's going on here. So, starting with the Z-axis, it's the simplest thing, and really this was just an experiment. I didn't think it was going to work. It worked just great. I've got rotator cuff surgery done on my right shoulder, and I just physically found I was unable to crank this thing for more than a few seconds before my shoulder really gave out. So I knew I didn't even want to preserve the crank. It's useless to me. So this wiper motor is basically hard connected directly to where the crankshaft is there. The crankshaft has, if I recall correctly, a quarter 20 thread on it. And just as luck would have it, these wiper motors, which I'll link below, have quarter thread on them as well, quarter 20 thread as well. So just as a quick experiment, I just hacked up a little sleeve in this aluminum block, which is just a cover, is probably an inch long aluminum sleeve with a quarter 20 thread running all the way through it that just couples the motor directly to the motor shaft. I just removed the crank handle here and put the wiper motor directly coupled to the crankshaft screw there, and then just tried it, and it worked. So then I said, well, heck, I'll just build a little frame around this to make it permanent, and this has been working really well. So now the wiper motor, as it turns, as it brings the mount up, it's turning clockwise, so it's tightening into that thread, right? Now, as it comes down, it would be trying to loosen itself off that thread. Now, obviously, I've Loctited both parts of those things together. I didn't use a set screw, so I didn't want to make it that permanent. They're just Loctited together, and the risk is that as it comes down sometime, if I had, let's say, the Z-axis lock on, that might make this motor try to unscrew itself from that threaded connector. But so far, I mean, I've been using this for quite a while. It's just never happened. I'm careful not to leave that motor lock on, and it works great. So this little little aluminum block here is just acting as a spacer with a big hole in the center of it to let that connector inside it. And then I've got another little plate on here which is mounted to my block, screwed in this way, and then another plate that is mounted to the motor that allows me to connect the two together. Right? This is now threaded into this, and that's really it. It was so simple, and it does the job great. As for power supply, I'm using the same power supply for both my X and Y feeds. It's a 480 watt. It's 0 to 48 volt adjustable. I've got it adjusted for, I think, about 16 volts right now. So I'm driving these a little fast. These are 12 volt motors. I'm driving a little higher voltage just to get some more speed out of them. And because it's pulse width modulated, they seem to be just fine, even at full speed. So generally I run my Z motor at full speed, 100%. There's hardly any reason to slow it down. But this is plenty fast, certainly faster than I could crank it. Up and down, no problem. If I'm running less than full speed, which I do sometimes for fine adjusting, this will instantly boost it to full speed, right? That's pretty typical. So I'll show the insides of one of these boxes. They're both identical for my X-axis and Y-axis. The only difference is I mounted the Z-axis, Z and X. I mounted my Z toggle switch vertically, and I mounted my X toggle switch horizontally to make it clear. Okay, so moving on down, try to do this all in one shot. Moving on down to my X-axis power feed. Same motor, exactly the same motor, and I'll link it below. It's a good little motor that's geared, it's got its built-in gears. Now, I didn't want to mount this directly to my X for two reasons. I mean, I could have the same disengagement sort of arrangement as I have here if I was to mount it over here. Similar to Phil Vandelay's got a video on that, where he mounts his on the other side, but he's got a similar kind of disconnect like this. But I wanted access. I didn't want to remove my X-axis handle, so I really wanted my handles still maintained on both sides. Because I do use them quite often, depending which way I'm positioning my body on the lathe. And sometimes I use them both, on the mill rather. Sometimes I actually use them both just to get fine tuning when I'm trying to dial in a number on the DRO. So in order to preserve the handles, I arranged this sort of a pulley system, a belt drive system here, where I've got a little belt drive pulley on directly mounted on the shaft here. And then I've got a tensioner here, which turned out not really be necessary, but it's nice just in case there was slack in that belt. And then the other pulley here is on two ball bearings. There's a ball bearing on the outer piece of metal here and a ball bearing inside this piece of metal. So that runs on bearings. And then the motor, so this is just a bolt, runs through here. And the bolt running through those bearings is a 1/2-inch bolt. And then I used a 13mm socket on here just to give a little bit of slack. So, 1/2-inch, 13mm is about 0.51. So it's a little sloppy fit on there, just lets it slide in and out easier. This is drill rod, 1/2-inch drill rod with 1/2-inch bronze bearings, make the slide nice. And so this works really well. And wiring-wise, normally these motors, these 12-volt car motors, have a common ground that's on the frame itself, right? The 12-volt DC ground would be the frame, and there's also a black wire comes out but these are wires wired directly to ground. And then there's a fast and a slow speed with the red and the green wires. Normally you'd use the green to ground is slow and the red to ground is fast. What I found, I wanted to, isolate the ground because I can't have two motors, both with ground, trying to go positive and negative on the same ground, obviously. So when I hooked up this, I learned that pretty quickly. I can't have both motors running this mill at the same time using the same common ground, because sometimes that ground's going to be positive and sometimes it's going to be negative in this application. So I found a simple way internally, just to take apart this the motor case here. I found a simple way just to basically cut the ground wire, which is connected to the frame, and then the red and green together, using them instead of the ground, actually give you more speed out of the motor. So it's like running the fast and slow together, and they sort of combine to give you a faster speed motor, which worked out beautifully on this on the X-axis. I wanted some more speed out of this thing. The Y-axis works great. Here I'm just using the traditional red, which is the fast speed, and black, which is ground, and that works fine for that speed. Maybe I will isolate it sometime later, but right now it's fine. But I really had to isolate the ground on this X-axis mount so they wouldn't interfere with each other. Okay, well that's a really long introduction, and I did it in one take, first take. Hopefully it's legible and meaningful. I think next I will take this apart just to show you the innards. I actually made this pretty much in place. I don't have any Fusion 360 diagrams for it. I'm just not a good Fusion 360 guy yet. I did do a Fusion 360 diagram of this end. I took pictures and did a really pretty accurate mock-up of the end in Fusion 360, and then I started to mock this up in Fusion 362, and I just said, I'll just prototype it on the mill as I go along, and that worked out. So not quite in one take. I realized as I was getting my tools out to take this apart that I never showed it in operation, so I should do that first. So here's my X-axis power feed in operation. It's the bottom of my two controllers here, and there's, that activates the motor. Obviously it's not engaged now, but that's the motor left and the motor right. And speed control here, just a 0 to 100 kind of speed. I tend to run this X-axis at around, and it's anywhere between 50 and 75%. Full speed is pretty fast. Here it is in operation. So let me run it, let's say at 75 here. So it just engages like that easily. And there it is going left. You see that's pretty good speed on the crank right there. About as fast as you could crank by hand, I think, if you were really pushing it. And there it is going right. All I've done so far is taken off the crank handle. I just wanted to show a couple of things before I go further. One is that I machined the crank handle recess here just a little bit because I've added some extra thickness with this pulley. When the crank handle goes on, it doesn't go down quite as far as it used to. So I just machined the recess of this crank handle. Oh, I think I only took off maybe less than a 1/4 inch in the depth here, just so that I could get a good purchase on this bolt, on this nut that holds it on. Okay, that's one thing I wanted to show. And the other is the limit stop. Obviously, you don't want this motor to run all the way against, to run to the end of the table, because it would, cause damage to the motor, pulley, maybe the mill itself. So down here, I fabricated this little bracket here that has limit switches, little micro switches in both directions that will bump up against these stops that I fabricated, good strong stops on both sides. I would say that one way down here. So I can just show you that in action. If I run the motor towards the stop, I'll even go full speed here. There's 100% speed. That's how much I trust it. Now as it contacts that stop, it's going to stop the table automatically. See? And likewise, now I can run it the other direction, get it away from that stop. And if I had time to show you that the other one come all the way down here, then it would obviously stop in the other direction as well. Okay, turn that off. Now there are also stops on the Z-axis, similar. So there's my DRO for the Z-axis, and there's my stop for, and it just stops against the same bracket that I use for my DRO sensor. So the readout here on the DRO is in behind here. I fabricated this little bracket, and this bracket corner here will contact that Z-axis stop. And similarly, there's my upper limit on my Z-axis stop. And again, as I continue to take this apart, I'm thinking of other things I meant to show you. These two simple little circular clamps here I just hacked up on the lathe just ride on this 1/2 inch drill rod, and they have set screws in them so that I can move them where I want, and they just set the position, the limit position of the travel of this. This is like my clutch on and off on my motor mount here. And some more details as I take this apart. The belt is a 400 2GT-6. Here's more detail of this little idler. And on the bottom, that just holds a little stop plate in here, which then has another little screw to hold a spring from moving, a screw on each end there to hold a spring. And so this spring then provides the force for that idler to push down on the belt to tension it. Okay. Look at the back side here. You can see the back end of that 1/2 inch bolt is sitting in there in a bearing. I'm going to take it out in a moment. And not too much else to see here. So with the motor now off and just sitting here loosely on my vise, I realized I was wrong earlier. Yes, it's a 1/2 inch bolt, but a 1/2 inch bolt has a 9/16 head on it. And so the bolt on the end here that the motor contacts is a 9/16. And then for the sloppy fit, I used a 15 millimeter socket. So that's a 15 millimeter socket on there. And what I did to attach it, I don't want to take this off because it's really thread locked on there, actually retention compound on there pretty well. But I actually drilled through that 15mm socket, you know, the square shank at the end that normally go on a socket wrench. I drilled through that to a diameter that would let me thread that on. I then put threads on it, and it worked out pretty well for that quarter 20 that's on the motor. So it's threaded onto the motor, and then to retain it, somewhere around the circumference here, there is a set screw as well to make sure it doesn't. Let me just turn this around a little bit if I can. Let me get the motor there. Where's the retention screw? Ah! There it is. Trying to hold my camera and do this work at the same time. So this little set screw I drilled and tapped into the side of that socket as well. So the whole thing is threaded onto that motor mount. The focus is bad here. Threaded on and then Loctited with retention compound and set screwed as well. So it's not going anywhere. And so the rest of this is just some metal to form the bracket, right? And there's my two bronze bushings. Okay, just a little pulley detail here on the X-axis. This is the drive pulley. So I just have a thin washer, then the pulley itself. Now the pulleys, when they come, they have a raised area here with a set screw in it. But I wanted to have the pulley as thin as possible because I wanted to be able to get my handle on there still. So I milled off that raised surface, so there's no set screw on it anymore. So instead, I just milled out a little area here to fit the original key. All right? So the pulley slides over the key, and there's enough of that key left to engage with the key and the handle and the crank. Okay, so that's the detail there. So just showing some parts here, a part on the workbench. This is the innermost base plate. So those three holes I just showed are those three holes, mounts on the mill, like so, right? And this top base plate mounts on top of it, like so, with those additional three holes. And then these two go all the way through both pieces to make it very secure. Okay? Actually, those three go all the way through. Yeah. And then the bottom plate, won't bother taking this apart, it's very simple. It just has this little standoff riser here, which eventually holds onto this piece, whoops, this piece like this, which is what holds that bearing and bolt assembly in place, right? That's going to hold the top bearing for this assembly. Okay, I'll show a video of it all going back together again anyway. Anyway, there's the pulley assembly, and again, I've milled off most of that inner race. What I did here is I just inched up on it. So there's the, what's left of the set screws in the original flange there. And I just inched up on it to make this, precisely the right thickness I wanted, so that when it's all together, the bearing's in the right position, basically. And I have a little spacer here for the inner bearing so it doesn't ride directly metal on metal. So this rides on the inner. Well, I'll show it as I put it back together again. Just dimensions here, just in case anybody wants to follow along. This is, there's nothing precise here. It's just I made it in place just to suit a particular belt I had. But you can make this, you can adjust these dimensions a little bit as to suit your own needs. So this base plate is about 5.5 inches long. The upper plate, likewise, 5.5 inches long by about 1 3/4 deep. I arranged them both so that the upper surfaces would line up with the upper surface of the mill table, of course, so I can get material over top of them without interfering. I already showed the pulley, a little idler pulley here. Here's the bearing that this will ride in on this side, right, with a spacer. But again, I'll show it all together. So that's basically it. Again, on this this pulley here, I milled out a little slot there for a key. Likewise, in this bolt, I milled a little slot for a key, so the you know, can be no slippage there. Okay, so I won't take this apart because I realize I use retention compound in there just to make sure it stayed together. But you can see here's the it's a 2-inch long by half-inch bolt. Made a little spacer there to ride on the inner bearing here, so this bearing's free to rotate. There's a little washer in behind this bearing between the pulley, again to make that bearing free to rotate. Then comes the pulley itself on the keyway. Then when I finally assemble this, there will be still another little washer that's going to go on there, and then finally the nut that holds it on. But I have to assemble it into this bearing first. Okay, so I'll do that now. Now here you can see the back side. This is the outer base plate with the drill rods in there, the half-inch drill rods. And I drilled right through and just used retention compound to hold them in place too. Just another little detail. This pulley idler, it's just held in there. It's got its own little tiny bearing inside it. This came with the idler, with the bearing. I think that's an M4 screw holding it to the main part here. And then just the detail is I made that screw go all the way through, and so it also acts as, you know, to retain this. See, you can just barely see the start of a slot there in the bottom. Well, that slot goes from, you know, there to almost the bottom. So this thing can't go any further than that. It retains it in there unless you remove that. Okay, small detail. Okay, and I'll just show this all going back together again, best I can. There's the pulley assembly again, built out with this bearing free again. Okay, so it's going to go into the front plate here. No washer required because this flange, the diameter here, will spin directly on that inner bearing there. Okay, so that's free to turn. And then flipping it over, I do use a little tiny washer here to sit on that inner race, inner bearing of the ball bearing. And then the nut, which I will Loctite on with some blue Loctite. Get it off again in future if need be. And there's the 9/16 nut. And we'll get it put on there. Good and tight. Okay, so now we've got a bearing. A pulley rather, riding in that bearing. And then, as I say, this bearing here is now going to be a captive bearing once I get it all put back together again. So let's see, this goes on here first. This is the base plate. And it fastens on in a couple of ways. You see this piece here is bolted in the bottom here with recessed screws. This is going to go in here with one screw in the base. There's only one here, but this will end up getting clamped together a whole lot more once these screws go in, right? It's going to clamp it down. This is really just holding this other end loosely during assembly. It will be much, much tighter while it's all on the mill. So I'll throw that in there. Then this piece here is the top clamp for that's going to ride on that bearing, recess for the bearing there, goes on like that. And it's a tight fit. And then these two screws hold it in place. Oh, I had to notch the top here a little bit for clearance around this rod. No biggie. Let me get those guys in there. Watching this assembly real time. Assuming I'm staying in camera. And that's that. So now this thing has, you know, supported on bearings on both sides. Okay, oops, my little spring came out. I'll just show you here this, I just put a little screw in the top and the bottom there, machine screws to hold that thing in place so it doesn't go around when this thing's going back and forth, right? Now you're looking at the right end of the mill here. I don't know how well this is going to show. It's kind of cramped quarters in here for me. Just to show you the again, the 5 mounting holes, 1, 2, 3 there, and 2 more here, line up with the 1, 2, 3, 4, 5 here, right? So this is going to go in like that, and then 5 mounting screws in here. Put them in loosely first, and then I'll tighten them up in a bit. And bring them home. Okay, I won't make you watch all this. Bring you back when this is installed. And at this point I realize I made a little mistake. I have to put the drive belt on before I clamp that pulley entirely in place. There's no way to get it on there otherwise. So let me just take the motor back off again quickly. Take this little end cap off again quickly. Make sure my arms are in the way here. Slip the pulley around the drive belt. That's the important thing. Then I can put this clamp back on and tighten her down. Okay, now I'm just trying to show the installation of the drive belt here. Again, it's over this end pulley here where the motor's going to go, under the idler, and then onto this pulley. Now it's a very tight fit. It turns out I didn't really need this idler because the belt is pretty snug as it is. When I made the dimension out of this pulley here, I just sort of had to guesstimate. I didn't have any way to actually know for certain, and I center punched it and then drilled it. Turned out to be a pretty tight fit. So anyway, I find the way to get this pulley on now is to get it all lined up like that, and then turn the end crank here, as you would with any kind of pulley, to get it to ride over top of the mount there, and there we go. All right, so all set to go. Just to put the engine on again, the motor on again. Slide it on like that. Don't forget my little end stop here. The little set screw has gone loose. Set screw back in the end stop. And the end stop back on the shaft. And then set the distance about there. And tighten it up. Okay. So then the final step is just to put the handle on. And again, the keyway here, get it at the top so I can see it better. The keyway will also go into the keyway of the handle. And there we go. And then just a washer. And again, I recess that so there's enough purchase for this nut to get onto all the way. And that's that. Job done. Oops, probably too snug. I need to get these a little bit of slack because those bearings really clamp down on each other. Okay, we're good to go. All set. Test. Sure. Test. All good. Let's see if I can show you the detail of this little limit switch assembly here. It's just a little aluminum cover I put on to protect the innards. Get it off of here first. I've got one of these screws is much shorter because this cable comes in and it would clamp down on the cable. It actually does clamp down on the cable to hold it in place. Okay, so this is a piece of old, I used this cable from an old DRO, same stuff as the standard DRO cable uses. I had an old one, extra length, so I cut it off. It's 4-wire, which was perfect. So my 2 limit switches are really, jam-packed in here. I made this piece out of stainless steel, milled it out to fit these 2 switches. In perfect hindsight, I should have made it just, 1/4 inch wider. I really had to do all sorts of gymnastics in here to get these switches so close together without actually making contact with each other. I should have given myself a 1/4 inch extra clearance. There's no problem with this being wider. It's bolted onto the mill. 2 new holes. Oh, sorry, those are the original holes that were the original guy was bolted onto, but I made it much stronger. And then these 2 holes here, I don't know what they're for. Some mill accessory, but I don't use it. But I figured I'd leave the holes accessible by just carving away the shape there. And that's it. And then drilled and tapped with that cover plate. So basically, these are just normally closed switches. They're wired for normally closed, and when that does that, that opens them up. And that triggers the little control box there to turn off the power. So the final thing I really should show as part of this video is, what's inside these control boxes. Again, the Z and the X are identical except for the location of the orientation of these switches. I'm sort of running out of time today. I've got another engagement to get to, so I'm just going to leave this video at this. If you guys want to see me take one of these things apart, please leave a comment and I'll do so. And you see I've got connectors on here. These each have 4 wires that got power coming in. This is for that cable that's going down to the limit switch down there, right? So power coming in, then power going out to the motor. That's the motor drive, similarly up here. Pretty simple wiring inside with a pulse width modulator from off eBay. They're like 12 bucks. Little buddy box. It's really just fits this stuff nicely. 10K potentiometer. This is the override for the speed, which basically just sets the potentiometer to full speed, and your back and forth switch. And the the direction switch is what's wired into the limit switch basically. So at the neutral position it's off. So that's exactly what the limit switch does. It just when it makes an open circuit, it just breaks the connection to the forward and or back, whichever way you're going. And this comes with the kit for the pulse width modulator unit. And simple to mount in there. Okay, I gotta get going. That's all for now. Hope this is helpful. Check in soon. Bye-bye.